Good afternoon and welcome to today's webinar on managing heat stress, the role of housing, nutrition and behaviour. So just some housekeeping bits before we get started. This session is being recorded and we aim to get it out to you guys over the next couple of days. Just to keep everything running smoothly, we have muted and turned off all cameras just to minimise distractions. And if you have any questions, we do have a Q&A at the end, so just put them in the Q&A or chat box at any time. So on today's agenda, we'll be covering 3 topics. Marie Haskell will be covering the behavioural aspects of heat stress. Mark Scott will be presenting feeding for resilience. And then finally, we have Chloe Rodriguez talking about THI and housing. And then at the end, we'll have a few questions. So moving on to today's speakers, we have Marie Haskell, who is Professor for Animal Welfare Science at SIUC. Animal behaviour and how it relates to animal welfare is her main area of research. She is currently working on projects relating to how behaviour changes under disease, heat stress conditions, and changes in affective states in cattle. Then we have Mark Scott, who is the owner of Cow-Centric Nutrition Consultancy. Mark has been feeding cows across the UK since 2006, has a particular interest in heat stress in the UK, and has worked for the last 5 summers collecting environmental and performance data to understand the impacts on UK herds. And then we have Chloe Rodriguez, who is the Animal Welfare Specialist at Galebreaker, who has recently graduated from Harper Adams University. Chloe has a passion for advancing livestock health and welfare, with a focus on delivering long-term benefits for farmers. I shall now pass on to Marie for the first talk.
Thanks very much, Amelia. Thank you for the introduction. Can we go to the next slide, please? So just to kick us off, we just need to kind of understand what the background is here. And obviously it's about global warming. That there is an increase in average temperatures across the UK, an increase in extreme weather events. And this is a global phenomenon, but we're starting to see things actually change in the UK to the point where, you know, people are starting to wonder about it. And what's what we're talking about here is heat stress in dairy cattle. And there's been quite a lot of work done on it, particularly in places like Florida, US, Australia, New Zealand, where actually it's become a serious problem, or always has been. And we know from that sort of work that there's a reduction in milk yield, fertility and health due to heat stress, and also that there's a welfare impact. There's a negative experience. The way the animal experiences its world is adversely affected by heat stress. And we're going to go into these aspects a little bit more in the next slides. So just a bit of theory. So why do cows experience heat stress? It's all because actually they are producing a lot of heat. So particularly a ruminant, they are ruminants. So fermentation in the rumen creates heat. And, you know, a high yielding animal is eating a lot of food, goes into the rumen, gets fermented, produces a lot of heat. So this means that particularly high-yielding animals produce a lot of heat. But animals are good, really, at trying to control their own bodies and control their own environments. So they try to lose that heat. And they do that by a number of behavioural and physiological means. But just there's a little graph there that shows what we call the thermal neutral zone. So actually animals can operate within a thermal neutral zone, and it's considered to be -15 to +25, and that's where the animal can operate without big physiological or behavioural changes. But within that is a thermal comfort zone where they don't have to do anything, and it's hard to define that because it changes with the type of cow you're talking about. Okay, next slide, please. So how do we really understand, well, what metrics can we use to kind of say we're expecting a cow to be heat stressed or not? And this grid called the Temperature Humidity Index, or THI, which you'll hear a lot about, has been developed well, over a long time, probably since the 70s. And it takes into account the fact that it's not just how hot the temperature is that matters to the cow, it's how humid it is. Because when we think back to what we were talking about in heat production and heat management, the cow is trying to lose heat by sweating, by moving to cooler places. Now, high humidity means that the sweating doesn't help really. If you cannot use evaporative cooling, losing heat by, allowing water and sweat to evaporate off the hide, then it restricts the animal's ability to lose heat. So that's why they've combined it together. There are actually other indices that take into account, whether the sun's shining on the animal and so forth, but this one is the one we use the most because it's easy to use. And you can see there's different colors there. There are grades of heat stress, from no heat stress at low temperature, low humidity, right up to cows dying. But we do say that about 72 is about where animals start to experience heat stress. Thanks. Next one. So the physiological responses are that cows will respond to heat stress by reducing their feed intake, because they're kind of almost genetically programmed to understand that it is eating that is causing heat production. So they kind of reduce their heat load by eating less or by eating foods that don't produce a lot of heat, such as roughages. They also put more energy toward heat dispersion. So there's more blood flowing to the skin to release heat out of the body, and they start panting. Now, so you've got two factors there. More energy is putting towards heat dispersion, and they're eating less. And this is probably why milk yields drop. Fertility is also affected by heat stress, and that's probably because, because of this energy partitioning elsewhere rather than to showing estrus and maintaining a pregnancy. So what you see is that cows will start to try and lose heat by panting. So that's kind of forcing hot air out through the mouth, getting cooler air in. Drooling as well becomes an issue. The same sort of thing happens. I mean, high respiration rate is that they are panting a lot. They are, their respiration rate rises in order to try and lose heat. They sweat, which is another physiological response, trying to use evaporative cooling. And they have low heart rate, which is an indicator of stress. So what happens to the behavior? The thing that we often talk about is that there are effects on lying. So lying time declines as THI rises. So here's a nice study done in the US in Wisconsin, and you can see that the bars, what they did effectively was look at behavior across a nice period where the temperature and the THI was rising, so a heat event that they could predict. And the bars are what the THI was in their shed, and you can see it rises. Can you click on, please? There's probably a couple of builds there. And what you can see is that the lying time, which is that barred and dotted line, falls across that period. So it falls from about 9.5 hours per day to down to 6.2 hours a day. And you can see that the solid line is how many lying bouts they do, so how many times they lie down stays about the same, but the dotted line indicates that the bout time gets shorter. So they're lying down the same number of times, but when they lie down, they're lying down for a shorter period, which overall gives a shorter lying time. And you can see that's probably not very good for milk production or health. Now we're going to talk about feeding and drinking. So cows will increase their water intake. Not surprising, they are losing a lot of water through sweating. But somebody has put a figure on it, and they've discovered that cows will drink up to 1.2 kilos more water for every degree of heat raised above the typical ambient. So if you calculate that up, that means that they're drinking 6 kilos more water if the temperature goes up by 5 degrees above what they're used to. So you can imagine if that's 6 kilos or 6 litres of water multiplied by 100 or 200 cows, that means you've got to have a lot more water coming into the shed. And they've also shown that cows will prefer chilled water. So if you offer them, water at ambient temperature, say 25 degrees, or nice chilled water at 10, then they will drink the cold water because that helps them keep cool. And it does have an effect. The body temperature comes down and their panting or respiration rate falls. So it's a useful thing to do. One of the big headline behaviours is about feeding behaviour. Here's another study where they artificially induced heat stress by putting cows into a thermal chamber and cranked up the heat to 29 degrees and the humidity was at 50%. Now, if we look at we chart, it falls into the green range, which means they ought to be experiencing mild heat stress. But you can see from the top graph and the red box that at day 0 in the middle there, when they applied heat stress and then held it at that level for 5 days, that the feed intake declined sharply. So it went down by 14.6 kilos a day. So that's considerable loss. And you can imagine what it does to milk yield and what it does to the cow's well-being. So the bottom graph shows what happened to milk yield as well. So it fell as well by 11.8 kilos a day. So quite a substantial loss when you get to something that is still only in the green level or relatively mild. And what do cows do in terms of behavior? They are kind of programmed or have an instinctive response to seek out cooler areas. So you can see them in sheds. They will go and stand where there's a bit of airflow coming in, or where there's a bit of shade, or whether they detect that the temperature is a little bit cooler. And this behavior of bunching, where, it's sometimes observed that in hot weather cows, it seemed to stand together in one place, which seems counterintuitive because, you stop the airflow then. But it may be this tendency of animals to seek out more shaded areas or darker areas, which they think ought to be cool. And when they're at pasture, they will seek shade. So this is a picture from New Zealand of a study done trying to look at how you would provide shade at pasture. And those little structures have shade netting on them of various densities. And you can see that the cows have stood in the places where the shade seems nice and dark, and are avoiding the one at the front right, where they've obviously got shade netting that doesn't hold back so much of the solar radiation. So yeah, those studies show that animals are very good at seeking out shade and using it. So as well as that, we have to remind ourselves that it's not all about physiology and behavior. We're actually having an effect on the animal's mental state or how they feel. So this is just a diagram from a group in Canada who thought about, well, what are the animals likely to be feeling? Well, of course, they're going to be feeling thirst because, they're obviously trying to drink more. They may well be feeling hunger because their body is telling them not to eat, but their level of food intake is down a lot. They may be feeling frustration because of all of this, that they can't eat and drink and they or lie down. Aggression increases because they may be competing for access to these places where it's cooler in the shed. And actually, they just may be feeling a bit rubbish, feeling malaise, that it's, they are feeling unwell at that time. So just a couple of slides about a study we did to say, okay, well, 29 degrees and high THI, we're not going to get that in the north. Will we actually get that in Scotland? So we did a study on our own farm, which is in Dumfries. And what we did was kind of say, okay, let's compare some periods when it was warmer with some periods when it was colder. So we defined a warm period as a THI over 65 and a cool period of less than 60. When you look at THI 65, it doesn't really even register. Cows should not be feeling heat stress at that time. So we kind of compared these periods and we found that there was an effect. It's not huge, but the lying time was shorter in the warm periods by 33 minutes. So it's not had a huge effect, but still something is happening. Cows are feeling that heat and humidity. Next slide, please. And the milk yield dropped as well, not hugely, but by about 0.8 litres a day. So it was highly significant. We had lots of cows, but there is a milk yield effect. And they began to drink more. So their intake was higher per cow on those days. So from that, we concluded that, even under conditions that were not really registering on the THI chart, there is some effect. So probably what is happening is it's continuous from everything being absolutely fine to, the heat stress having more and more an effect and cows making more and more changes to their behaviour to the point where actually it starts to becoming damaging. Overall, we can say that, milk yield and fertility is negatively affected. We can see changes in lying time and feeding times, which are reduced, and drinking is increased as the cows try to adapt. But even mild heat stress has some effect. We just have to figure out, each person or each farm has to figure out when it becomes important to act. And what farmers might do actually is to take some measures to, at that point, like increasing airflow or changing the feeding. But we will be getting increased frequencies of heat waves or overall ambient temperature in the future. So these interventions are going to become increasingly important. And thank you very much. That was all I was going to say. Thank you.
Thanks, Marie. I will pick up from here then. So good afternoon, everybody. Mark Scott, Cow-Centric Nutrition Consultancy, and Mia introduced me earlier on and explained a bit of my background. So yes, quite an interest in heat stress, specifically in the UK, because I think Marie covered, there's a lot of crossover between our presentations, so that's a good thing. But yeah, there's a lot of work been done in the States, but we really concentrate on what's in the UK, and some of the things that Marie even finished on there really is that certainly our cows in the UK, and even if you go a little bit further into Northwest Europe, our cows are just not adapted to the changes in temperatures, and now being a very good example where we're hitting kind of 26, 27 degrees in some sheds in the UK, and then it'll probably be down to 8 or 9 degrees overnight. So there's quite swings in the temperatures. So anyway, I've been asked to look at managing heat stress and the role of nutrition. So we'll cover some of that with a bit of scene setting. So I always like to start with a bit of heat stress perception, because I think that's where a lot of the kind of misunderstanding of how cows perceive heat stress. So human beings perceive heat stress from a THI of around 80, as opposed to, Marie touched on it earlier, but cows perceive that THI from around 68. Now that's interesting, but it's not as interesting as actually understanding what the heck that means, because nobody ever wakes up in the morning and says, oh, I wonder what the THI will be today. So if you give it another click, Mia, we can see some numbers. The reality of that is that for a human, even on a day like today in the UK, yeah, it's gloriously sunny, early May, it's going to hit about 26, 27 degrees. That's not too bad for us. We won't mind sitting in a beer garden in one of our pubs and having a nice beer later on. But for a cow, it's particularly uncomfortable. They're experiencing heat stress from around temperature of 22 degrees Celsius. And the reason they come to that number is that on average in the UK, our humidity is pretty high. So it's around 60%, rarely going below 50%. And certainly overnight, even in the summer, hitting up into the 70s and maybe even 80%. So, yeah, the cows experience heat stress from around 22 degrees Celsius. And so we really need to understand that on top of all that, if you look at your weather app today, for example, and it says it's going to be 25 degrees where you live, that means it's probably going to be 26, 27, maybe 28 or 29 degrees in sheds, because it's always warmer in the shed by between 2 and 6 THI points. So that's between 2 and 6 Celsius. And that really does depend on the shed, because I've seen variances just on one farm between different sheds. So yeah, so think about it. Today's 25 degrees, could well be 27, 28. So cows will really be feeling the heat in that one. So this is an expanded version of what Marie presented. This is what I perceive as being the well-known THI chart, showing you where these cows are experiencing heat stress and what the effects are. I haven't got a pointer, but as you can start in the top left and you work down, you go from no stress to the yellow ones where, yes, we're at the stress threshold. The orange is mild to moderate and red is moderate to severe, and so on. What I'd like to draw attention to for us in the UK is if you click again, Mia, we're really only looking at that is not covered. As I said, humidity rarely goes below 50, probably averages 55 to 60 most days in the UK for a 24-hour average. So really we're looking at those numbers. So when suddenly 22 degrees, yes, it is going to be a problem. And like I said today, if you track that down again, sorry, I haven't got a pointer, but if you thought some of the sheds in the UK might be 26 and 27 degrees, they're probably looking at THIs of 73, 74, 75. So that is getting towards a tipping point of certainly you'll be noticing animal behavior changes, respiration rate increases, more cows standing when they shouldn't be, voluntary standing going on, more cows at the drinker, and probably empty drinkers, because that's a really big challenge on a lot of farms. And of course, this doesn't account for internal body heat. This is just external. This is the environment. So you can see here, these are two graphs these are real farms in the UK, where you can see the impact is on milk production and reproduction. So the graph on the left of the screen is milk production. You can see the blue line is milk production. These cows are ticking along around 39 to 40 kilos of milk. We get a heat event in July 2021, and you've got a big drop in milk. You've lost 7 litres there with a big, and that is quite a severe heat wave for the UK. Hitting those daily average THIs of 75 is really unusual, but you can see the impact there. There were some fans on that farm, but there was no other mitigation, but not all of the sheds had the fans in. They took nearly a month to recover back to 40 kilos, but you'll see in September they had another dip. Move to the next graph on the right. That's fertility on the right. And basically, when you get that average THI on the red line, when it goes above 65, that's when your conception rates drop. So the blue line shows that that farm is averaging around 35 to 40% conception rate. But when you get that bigger heat event again, that mid-late July of the same year, they've gone from 40% conception rates to under 10%. So these are big things. However, as it says on the screen, they're not instantaneous. We normally see those things when we look back. So you're looking at physiological indicators that Marie talked about with respiration rates, standing behavior. Respiration rate is so easy to measure. Walk into any shed, get your phone out, set 15 seconds on your phone, press start, and stand and watch a cow breathing. When the alarm goes off, you've done 15 seconds. If she's done 20 breaths, times it by 4, she's doing 80 breaths per minute. So it's very easy to check respiration rates. But these thresholds are decreasing, by the way, due to genetic improvement and higher yields. And that's something we need to take into account. So next slide, please. This is one of my favorite graphs because this is when we started originally looking at heat stressors back in the 1930s. And you can see on the left, those cows on that study, 10 kilos of milk, 16 megajoules of body heat, okay? By the time we get to the turn of the century, which sadly for me and some of the people on this call weren't even born at that point, but the year 2000, 25 years ago, the turn of the century. But yeah, cows are averaging 30 kilos of milk pretty much and 44 megajoules of heat. So 3 times as much milk, 3 times as much heat. And they've got to get rid of that. Marie touched on that. So next slide, please. Oh, not next slide, sorry, next click on. But yeah, this again is another good one because it's 45 kilos of milk, the cow on the right versus a 32 kilo cow, and the body heat produced is 26% higher for the 45 kilo cow, and that's significant because those cows will be the same size and she's got a dispersed 26% more body heat. Now what's interesting, if you go back and you look at USDA figures in the US, not the UK, but you look at their yields have gone up by about 13% up until like 2018, so they've gone from kind of 9,000 kilos to 10,400 kilos. And the thought process there is that actually you've got an increase in milk yield from, say, 35 to 45 kilos for some herds as well in the UK. But that can actually drop the heat stress temperature threshold by around 5 degrees Celsius. So we need to take that into account when we talk about our high yielding dairy cows in the UK. 20 years ago when I started feeding cows, 30 litre average, 30 kilo average was high. These days, 40 to 40, we've seen 42, 43, 44, 45 kilo averages. A lot more body heat to think about. What happens? Marie touched on a little bit of this, but yeah, just to cover it again, hormonal intervention. So they get a hormonal intervention within the cow means a decrease in animal metabolism. So that then kicks into gear the decrease in feed intake. We see the increased vasodilation, so we see that increased blood flow to the skin to try and lose that body heat. Yes, we've got some other things going on with respiration rates, etc., but these are the kind of physiological things that go on that are governed by hormones. Just give it a click again. And so this graphic, don't worry about the detail, but I just wanted to show you all the things that are going on in the heat-stressed cow that impact on reproduction, from reduced feed intake through to disturbed metabolism in the liver, early embryo loss. We've got issues with the ovaries. We've got the rumen, potential with acidosis. But it's just to give you an illustration of all of the contributing factors when the cow starts raising her body temperature and she experiences heat stress. All that feeds into reproductive issues, basically, and a drop in fertility. So it is a physiological problem predominantly. We get an elevated core body temperature. We get this blood diverted to peripheral tissue. So we then can potentially see cell dehydration. So never mind cow dehydration, but cellular dehydration. So quite a technical thing, but basically what gives you is shock proteins within the cow. And those shock proteins are quite detrimental to cow health. And so we get a big issue there. We see that increased respiration rate. We've touched on it a couple of times already, but 40 to 60 breaths per minute is normal. Above that, we've got issues. And I've just said it's very easy to figure out what the respiration rate is. We see a loss of saliva, which is buffering capacity in the rumen. We have the energy cost of that increased respiration rate. And if a cow is doing 80 to 100, 120 breaths per minute, which I have seen in the UK very often, then they can't ruminate. And that's a big issue as well. And then we also have ruminal and potentially metabolic acidosis, and the picture on the right there is actually of a mucin cast found whilst muck sieving on farm, but that mucin cast is literally the lining of the small intestine being stripped away by feed fermenting in the small intestine, and as a result of acidosis in the rumen, and so overload in the rumen, issues in the rumen, and that's what we can see. We also potentially see an imbalance in sodium because this cow is now breathing more quickly and sweating as well, so we have to consider that as well, but it's predominantly a physiological problem to start with. So primary strategies to mitigate heat stress, what are they? Well, obviously it's looking to provide shade, ventilation, that's a specialism of Chloe and the Galebreaker team as well, and fans and sprinklers, potentially, not so common in the UK, but that's what we would look at. But nutrition also has a role to play, which is good because that's what I'm supposed to talk about. So next slide, please. So there's three things we look at. We've got heat load. So how can nutrition reduce the heat generated internally? Heat dissipation. How can nutrition help her to lose heat? And heat stress. So how can we counter the effects of heat stress? So we'll cover those one at a time briefly as we go forward. So the impact of nutrition on heat load. So to reduce the heat load on a cow, we need to minimize the heat of fermentation. Brackets counter the reduced dry matter intake as well, by the way. So we need to increase the fiber quality, so increase the digestibility of the fiber. So better quality forages fed in the summer might sound counterintuitive, but that will help because if it's easier to digest, it produces less heat. We might consider, it's not very common, but we might consider reducing the forage to concentrate ratio. We need to maintain obviously fiber so we don't get acidosis, but potentially you could look at that. It's not unheard of, but you could replace a bit of forage with some moist feed, for example, to achieve that without detrimental impact. But that's another way. So again, we're trying to reduce that fermentation load and that heat. Minimize heat of metabolism. So again, feeding a protected fat. Don't feed too much. We can have detrimental impacts on dry matter intake if we use calcium soaps, but that's just literally a bypass fat. Does what it says on the tin. Bypasses the rumen, gives the cow energy without adding to the fermentation load in the rumen. So they can be used. We need to maintain glucose levels because cows, when they're heat stressed, switch from mobilizing body fat for For energy sources, they want to use glucose because it doesn't create as much heat in their body. So we need to make sure there's enough glucose supplied, and that can be making sure we're keeping the starch levels at the right levels. But also we can look at bypass starch, again, taking a little bit of the pressure off the rumen, but not going too far, because again, we don't want too much acidosis going on in that cow, and too much bypass starch can create hindgut fermentation. So the next part is the impact of what can nutrition do to mitigate heat stress. So I've kind of moved it around a little bit because the next part is more important, I think. But when you get heat stress, what can you do to mitigate it? So you need to counter that dry matter intake reduction. Touched on it earlier, but increase the energy density of the diet, supply metabolizable protein and minerals and vitamins without inducing acidosis and SARA. Okay, so just increasing the density of the diet, i.e. a bit less forage potentially. You compensate for the minerals lost in sweating and increase respiration rate. So making sure we get the balance right with the potassium, with the sodium, the phosphorus, just checking all those things. And I'm not going to go into detail. We can talk about that. If people want to speak to me, you can get in touch, but I won't go into detail because it's a bit too much for right now. But we also need to support the body functions that are compromised by heat stress. Now, this is really common. You see this all over the place in the UK, advertised everywhere. Feed yeasts for heat stress, feed rumen buffers for heat stress. Yes, they have a place, but only really to deal with the consequences of heat stress. They don't stop it. But yes, ruminal and metabolic acidosis, feeding rumen buffers, yeast products, maybe mycotoxin binders, counter the acidosis and the potential for LPS, but they don't stop the heat stress in the first place. They just deal with the kind of the fallout from it. And also cellular hydration, we talked about it earlier, but feeding osmolytes, and we'll cover that again in a little bit, but they maintain cell integrity and internal organs. And again, that's a bit of a consequence, but it can help to reduce the impact of heat stress as well. From a practical perspective, what can you do? Feed at least twice a day. If you feed once a day, feed twice a day, maybe even feed 3 times a day. Feed more in the cooler times. So 60 to 70% of the feed offered overnight, because the cows will go and eat it, and it won't waste. So that's something you can do. Do we use TMR stabilizers? Is the feed heating up? If you're adding water, yes, it helps intakes, but don't add too much because it can destabilize the ration and get heating. The picture there is just to show that these are clever cows where they're kind of going, hang on a minute. You'll see closest to you, they've eaten all that TMR because that's in the shade. Cows have access to this full feed fence, and you'll see at the top end of the picture, this is taken mid-afternoon, they've barely touched that's in the direct sunshine, because they don't want to eat in the direct sunshine because it's either hot or perceived as hot. And so, yeah, is that stable? Should we put stabilizers in there? But cows will show you that through their behavior what they prefer. So they prefer to be in the cool, in the shade as well. So it's just a nice little illustration. Next slide, please, Mia. So this is nutrition and heat dissipation. How can we help the cow dissipate heat? Marie touched on water, and funnily, and we've obviously read the same places, because 10 degrees C is the ideal to get that water temperature. Not always achievable, but she'll drink more. It'll cool her from the inside out. They'll drink up to 250 litres a day. Some of these high-yielding cows, you might have cows doing 60, 70, even 80 kilos of milk. They drink a lot of water, and 30 to 50% more water through the summer than through the winter. Ensure that it's in a shaded area, it's fresh, and you've got a good refresh rate. So you've got a good flow rate, and you're not short of water in the troughs, which I've already seen in the last couple of days on farms. Flow rates aren't quite there for some people. And make sure you've got enough space. 10 centimetres is the target. One of the farms I checked last week, 5.6 centimetres. That's just over half of what they needed. And they seem to have a lot of water troughs. There wasn't enough water was in the shed. So think about that as well. Additives to increase evaporative losses from the skin. So there are products you can feed, niacin and plant extracts, help vasodilation, help them to lose that body heat. Additives reduce metabolic heat load and reduce impacts of inflammation, such as betaine. Now, these products, they can be standalone, but you really want to be feeding them in a combination pack, probably. I know literally 2 products on the market in the UK that mitigate heat stress. So i.e. these drop the internal body temperature of the cow only by 0.2 to 0.3 degrees Celsius, but they spend up to 50% less time above the 38.8, 38.9 threshold that you don't want them passing. Okay, so these are products you should be feeding to stop that heat rise internally, as opposed to dealing with the consequences. And finally, do not forget your dry cows. So cows suffering heat stress in late pregnancy can produce up to 4.5 kilos less at peak than cooled cows, and that's when they go into the same shed. This is an experiment where they were cooled or not cooled, and they went into a shed where they were all cooled, but still the ones that hadn't been cooled pre-calving produce 4.5 kilos less milk. So it is important to look after your dry cows. And also those calves born from those heat stress dams, massive knock-on effects. They're born earlier normally, so shorter gestation, which also leads to lower birth weights. And doesn't matter the quality of the colostrum, the amount of the colostrum, but they have a lower IgG absorption. So it's a real issue. So cooling those dry cows is really important. And there's been some long-term studies which prove that the lactations of those calves born from heat stress dams are lower for the first 2 lactations. That's as far as they studied. So they have a lower productive lifetime performance, so i.e. they leave the herd earlier. And then, funnily enough, even the offspring of those calves are impaired with their lactations when they're from heat stressed, they're born from heat stress dams. So there are knock-on effects. And what you've got to look at is go back to the additive story and say, can we make sure that every cow is cooled? Can we make sure that every cow gets the benefit? Whether we talk about, I've learned over my 5 years of studying this in a lot of detail that yes, you can put fans in a shed, but actually a feed additive that reduces body temperature will have as much effect as putting fans into a shed, because every cow gets the benefit of that feed additive, and not every cow gets the benefit of a fan necessarily, or not equal benefit, shall we say. Without wanting to offend people. But yeah, it's really important, and there's very few products around that can do that, so it's really important. But do not forget dry cows, and there are dry cow products that also do that, will drop internal body temperature, few and far between. But yeah, the real challenge here from a nutritional perspective is when to feed your cows, and then what to put in there, and can you feed something to mitigate the impact, because most people end up having to mitigate the impact because of heat stress occurring. And I think that's the last slide. And there we go. So thanks for your time, and I will pass you to Chloe.
Thank you very much, Mark. So yeah, I'm going to go over a bit more on the THI and the housing side of it. First, I wanted to start by setting the scene. As we've heard, heat stress is becoming a growing problem for dairy farmers, and it's not just now in hotter countries, but it is here in the UK. It can often be silent and gradual, and farmers in the UK actually don't often realise how badly they've been hit, but we know it impacts cow health, fertility, milk production, and as Mark just covered, that long-term effect on carbs and overall welfare. So you are losing that loss of performance, lost profit, but also that welfare side of it. And the reason why it's happening is that increased environmental temperatures that we're seeing, so more extreme heat events. Cows are being bred for higher yields, so we've got more metabolic heat being produced, and also many cows in the UK are being housed indoors. And what does an average UK shed look like during the summer? Like this. Cows are generating more heat than they can get rid of, and these are typical sheds in the UK and what we're seeing. So you see this classic bunching behaviour, empty cubicles, standing around water troughs. You see hotspots from roof lights, and you see a lot of perching. But these are really typical UK buildings. So it's really important that we need to keep cows cool to keep that performance up in the summer, and that will maximise the efficiency year round. So by looking at our temperature and humidity, we can then look at how we can improve housing and ventilation. I firstly wanted to give some real data that we've taken from a farm in the UK. And this is data taken from a project that we've been working on for the past 2 years, which is basically looking at how cow behaviour can then control ventilation systems. And this is where cows were housed in quite a typical UK dairy building. So it was cladded on the sides, it was dark, there wasn't much natural airflow. And over the project, we have made improvements, but I'll show that later. This data shows THI and milk yields from a hot period in 2023. So the top 2 lines are your high yield, the main milking herd, and then the bottom 2 are your heifers. The top line on each is your daily milk production, and then the bottom is something that we've used called adjusted milk, and it's basically to try and remove the variable of days in lactation. But it shows the effect from just one heat stress event in the UK, and how actually it can have such a huge effect on the herd. And actually often by the time that we see milk yields begin to decline visually, the damage has already started. So they'll already have increased standing times. The feed intake will have already been reduced, and hormone disruptions will have occurred. So it's just important to look at how one heat stress event can have an effect on that performance. And because we don't often get heat stress events, or we're not consistently hot over the summer, it doesn't give the cows that time to acclimatise. And that's why it's really important to measure, to try and detect that heat stress early and then manage it so you can be proactive against it. So I'm going to go over what is THI, why it matters, maximising that natural ventilation, and then where we can supplement with mechanical ventilation. So THI is the temperature and humidity index, and it's a simple way of measuring how hot it feels to a cow based on the combination of air temperature and humidity. Cows don't sweat efficiently like humans do, so they very much rely on respiration and thermal exchange to cool themselves. So even when temperatures don't seem that extreme to us, the high humidity can make them feel a lot hotter for them. And then that's where this temperature and humidity comes in. So in humid conditions, evaporation from the lungs becomes less effective, making it harder for cows to cool themselves. And this is particularly important when cows are producing large amounts of metabolic heat. So that's through that increased milk production. And again, by the time we're seeing the signs, often performance has already begun to decline. And by measuring THI, it's a really easy way to monitor and to see how our buildings are performing over the summer, and then we can make changes from that. So if you're not measuring it, you can't then manage it. So that we've been speaking about this a bit today, but actually THI thresholds. So quite typically, I'd say probably a THI threshold of 68 was given for where we start to begin to see heat stress signs. However, there has been some research showing that actually now maybe cows are beginning to feel heat stress at lower THI levels. And this is where above these thresholds, it's where cows begin to accumulate the heat faster than they can lose it. And the THI thresholds are beginning to decrease as we're increasing milk production. So they've got more metabolic heat to get rid of, and therefore they're going to start to decrease. They're going to start to feel heat stress at a decreased THI level. And that's really important when you're thinking about your heifers and your higher yielding cows. They're going to be beginning to feel heat stress at different thresholds. This is something that we do at Galebreaker, is we can take our THI data and then we can put it on what we call a heat map. So on the left-hand side, you've got your hours per day, and then you've got your average daily THI and your timeline. And this shows basically if you're having, for example, today in the UK, we're getting about 25 degrees, 26 degrees. So even though we will be experiencing heat stress in our buildings, because that THI is not being sustained, we won't then see as big effect as when we get these kind of sustained periods. So when we're having these THI levels and they're sustained in these higher thresholds, and this is where we really do see a big decrease in performance. So this is from 2023 when we had 2 quite significant heat stress events. But this is also taken from 2024, and I just wanted to put this in here because 2024, we didn't have a warm summer. So it's something that we think, oh, our cows weren't suffering with heat stress because it wasn't that hot. But actually, data taken from UK sheds do show that we were experiencing those higher THI thresholds for a considerable amount of hours, even though you can see where it does drop down, but it is still being sustained. We have now got a website called THI Live, and it's to try and raise awareness of heat stress in the UK. So what we've done is we put data loggers around the UK. We're then extracting that data and creating heat maps. And all it is a simple logger like this. And you can go to our website, and this is how it stands now. So here you can see all the live locations we've got. And so farms can go on, look in their area. They can click on the red flashing dot, and you can see how that building, what that farm is and how that building is. And you can see actually my building's quite similar to that, and that they're actually getting quite severe heat stress right now. So maybe I am too. And actually this screenshot was only taken 2 days ago. So like I said, even though it's nice weather for us now, it's quite hot in those UK dairy sheds. Another thing is building variation. The buildings are not uniform, and this is from a study we did on a farm in Wales, and from that hot period in September 2023. And actually, in this building, the fresh air was definitely hitting this end of the building, whereas this end was very blocked from the prevailing wind, and you were getting hotter areas. It was staying in higher THI levels in this end of the building. And actually, it's a behaviour that I've seen quite a bit on farm. But actually, this was the darker area of the building. And even though the fresher air was coming from this side, which was the cooler end, cows were bunching down the darker end. And I'll come on to this a bit later. But this is just really important. You know, buildings aren't uniform. THI can vary from one end of the building to the other. So common issues that we're seeing with housing, we're now housing all year round. We're reusing general purpose buildings. We're replacing additional buildings in close proximity. Buildings are not orientated right, so we're not getting that prevailing wind. And we like to build our buildings in the UK very enclosed, so we're limiting that fresh air coming across. And so what are we aiming for? We want to get that high airflow into that building to get that cooling effect, but also improve that air quality, reduce the moisture, try and remove the moisture and that heat that the animals are producing. And so that's where it kind of comes into the natural ventilation principles, which we often forget about in the UK. It's the most common, it's the most cost-effective form of ventilation. However, the sheds we're designing lead to inadequate ventilation, and therefore we get subsequent problems. So 2 ways natural ventilation works. You've got your thermal buoyancy. So that hot air that those animals are producing is rising because it's less dense, and that cool air comes in. And then secondly, you've got the wind. So this is entering through your side inlets. And this is what you want to maximize. And it's important to know that every building does ventilate differently. So what are your requirements? You need an exhaust, you need your side inlets, you need good building orientation, interior roof slope to aid that air movement, and no wind shadows. So when you think about your exhaust, in the UK, we commonly overlook this for both new and when we're modifying existing buildings. But this is where your exit for your warm contaminated air is going to escape that building. So on a summer's day, when you don't have that wind blowing, this is where that hot stale air is going to escape through the building. Quite often we see this kind of cranked ridge, and actually this is only offering 20% of the required opening. And you'll want to get about 5 centimetres for every 3 metres of building width. And if you can, you really want to maximise it. We see open ridges a lot. These work, and if they're the only option on farm, they work really well. However, you do in the winter months tend to get a lot of moisture in through these, particularly if they're over cubicles. And then you can have a ridge like this, and a light ridge, even better, you get that uniform light. But how it works is you want that wind accelerating over the top of the ridge, and it creates a positive negative effect, so you're getting a suction. Your side inlets, fresh air is free, so let's maximize it. So this is where in the summer months, you want to be able to open that building up, get as much fresh air into the building as you can. It needs to be at least 2 times your outlet to create that suction effect. And really in the summer, you're wanting 2 to 4 times. Typically in the UK, we see this on buildings, cladding, and then you even get this metal vent clad that we see, particularly in Scotland, where we have the more extreme weathers in the winter months. Another problem we have is adjoining buildings. So actually here, while you've got a perfectly good building, this middle shed is not going to be getting any natural airflow. Open sides, it's nice to see buildings going up now with no sides on them at all. And then you've got your automatic curtains. So this allows for good ventilation year round, because you can still control it a bit more in the winter months and protect it from rain, but you can then open up that building, maximize that fresh air into the building during the summer months. And with the great bit with this is you can have a fabric which still is porous. So in the winter months, it's still letting airflow through the building. When we think about having curtains, getting that curtain actually right down to nose height is really good to get that fresh air in that animal's microclimate. When in heat stress condition, cows want to stand up, and actually you want to encourage them to keep lying down. So if you can open your building up and get fresh air coming into that animal's microclimate. Roof pitch. So having this roof pitch will really help aid the air movement in the building. You want about a 1 in 4. So that means for every 4 units of horizontal distance, the roof rises by 1 unit vertically. So it's anywhere between about 17 to 22 degrees. Building orientation. So here, this is what I spoke about earlier. You want that prevailing wind passing over perpendicular to the ridge. One, this will help accelerate the exhaustion of dirty air from the ridge, when the air accelerates over. But also, you want that, like I said, fresh air is free. And if your prevailing wind is hitting your side inlets, you're maximising airflow evenly throughout the building. Whereas if you're hitting the end, you've got limited airflow passing through. And then, like I came on to, that space between buildings. We love to build buildings in the UK, a good building, and then we put another one next to it and another one next to it. And all we're doing is jeopardizing that air, that fresh air that's free, like I've said. So you need, if you can get about 30 meters between each building, you can then allow for each building to naturally ventilate and maximize that airflow in the building. Coming back to this lighting, so one behavior that I've seen throughout the UK over the last few years is we talk about this bunching behavior, and often we think that cows bunch where the fresher air is, which is right in a lot of circumstances, but actually I've been on farm where cows have bunched in the darker areas rather than where the freshest air is coming into that building. And this is a really good example on a farm in Herefordshire. At about 10 o'clock every morning, you have direct sunlight coming through onto these beds. And every morning through the summer, those beds were empty. And this is kind of the same effect that we can get with roof lights. And that's why we have had farms in the UK where actually we've painted over the roof lights, and then they've seen a really good improvement of you not getting hot spots on cubicles. But in this building as well, they used to bunch down this darker area. And I think it's because a cow associates a dark area with that shade. So it comes back to Marie's point. But it's just something really important to think about. And also that uniform lighting throughout the building. And often when we can take off cladding and side walls, we can actually create more uniform lighting along the building. Mechanically ventilating a building. So there's 2 ways you can typically do it. You positive pressure, so that's forcing air into the building, and then you push the air out through openings, and negative pressure, where you're basically extracting air from the building. Typically in the UK, we more use positive pressure. So we're putting fans in the building or positive pressure tube ventilation. So kind of your standard fans on farm. Fans have been adopted a lot more in the last 5, 6, 7 years. However, still a lot of farms in the UK don't use mechanical ventilation. And what you want is you want that cooling effect. It's that higher airspeed over each cow's back to create that cooling effect. Fans do that, and they have seen great results from it. However, the trouble we have with fans is electricity price in the UK is higher. And so where perhaps down a row of cubicles, we might need 4 or 5 fans to get the desired airspeed over each cubicle, we're putting 1 fan. By the time these cubicles are filled, these cows are not getting the same amount of airflow. So it's really important when we're thinking about putting fans in that we're getting uniform airspeed over each cow's back. Positive pressure tube ventilation, this is something that we've taken. It comes from the calf side of things. However, it's on a much larger scale. So you've got 1 fan which sits externally on the building, and then you've got a large sock that goes over each cubicles, and it basically provides a higher airspeed over each cubicle. So you're getting air distributed evenly down the whole shed, but also in each animal's microclimate. And it's also a more efficient system to use. So this is kind of how it looks. And the benefit is you're not fighting over that higher airspeed, and it goes into each cow's microclimate, so each cow is getting cooled. And we've done some development work on this, and we are now getting airspeeds of anywhere from 2.5 to 5 meters per second over each cubicle. This is some thermal imaging I did a few years ago, and it just shows really nicely a hot cow with no fans or no mechanical ventilation, and then that cooling effect that those fans, that mechanical ventilation, that convective cooling can get. A few weeks ago, I did a cow signals course, and one of the things that was said on this course is it's very easy for us to go into buildings and to just talk about what we know, what we specialize in. However, it really made it, they kind of used these three things, look, think, act. And it made me want to apply them to heat stress, because actually, let's go into a building, let's look at the cows. What are the cows' behavior telling us? What are the physiological signs? And then let's think about it, let's identify that heat stress risk, and then we can act upon it, we can monitor it, we can adjust it, and we can implement solutions. And finally, to finish off with, I just wanted to show these pictures. So this is the farm that we've been doing a study on. Very typical 1980 build, cladding, quite dark, not uniform light through the building. Slowly, we've started to add positive pressure tubes in, but actually this year, we've then stripped off all the cladding and we have put side curtains on. And one of the biggest differences, we're now getting uniform light throughout the building. So over this summer, we're carrying on the study. We've got a few really exciting technologies that we're using, and we're going to monitor how these buildings are now performing. Now we've made that those changes. So thank you very much. And now we'll go on to questions.
Does anybody have any questions? If you put them in the Q&A or chat box. So the first one's for Marie. Is it possible to measure or track the behavioural responses to heat stress on real farms?
Thank you, Emily. Yeah, it is actually. I think that first, we're often using technology to look at animal behaviour, so you can look at how much the lying time changes. And as Mark said, it's easy enough to measure respiration rate in cows. So that's another way of looking at whether they're experiencing heat stress. And yeah, I think that what Galebreaker are coming up with is, trying to map where cows are may also be another way of helping us. So yeah, we can. We've got increasing technologies to use.
And then one for Mark. Are there any feeding mistakes you commonly see that actually make heat stress worse?
A lack of understanding. I think I touched on it previously. One of the biggest things we see, or I see on farm, is, and certainly see in the press in the UK, is the kind of marketing of certain products as heat stress products, when in fact they're mitigating the impact of heat stress. Whereas I think we really need to get in front of the curve, so to speak, and be looking at products that will reduce body temperature, that will reduce respiration rates, i.e. reducing, the signs of heat stress, because these cows, they're on a knife edge and we really need to help them lose that body heat. I think we've moved on a little bit to going, okay, well, yeah, we can feed something to kind of mitigate the acidosis and things like that, and some of the other issues. But if we can stop them in the first place, that's a key one. And I think what shouldn't be overlooked is probably a combination. So it's making sure we feed the better quality forage in the summer, because people try to keep hold of it maybe into the winter, because that more fermentable energy, more fermentable forage produces less heat. And also I think water's just massively overlooked, like I touched on when I said, have you got enough space? I was on the farm, 5.6 centimetres of water space. So they need more, because you might not think you need more, but when it comes to the summer, they do. I was on a farm yesterday and literally, they're chasing water. These cows are chasing water. And in fact, 2 farms yesterday, it was both the same. Troughs, big troughs, but we've got big herds these days. Commonly see herds of 4, 5, 6, 7, 800 cows. So I think we need to upgrade our water systems as well, really, for the summer. And it's something that hasn't been necessarily addressed.
And then, Chloe, what would you say are 3 of the most important things to consider when you're designing a building?
I said it a lot through my talk, but maximize what's free. Look at how you can maximize that natural ventilation, and then we can supplement with fans when needed. But if we can put the building the right way, if you can have open side walls and you can have a good exhaust, that building will naturally ventilate really well. And then if we are still getting heat stress in the summer, then we can start looking at fans, positive pressure tube ventilation, and we can then get that cooling effect with that higher air speeds. But let's maximize what's free. That's, we need to start trying to remove sidewalls, get fresh air in and into that animal's microclimate, and also get hot, stale air out that building, get it exhausted out the bridge.
Just to add to that, Chloe, I think it's been said different places I've been, we need to build, and it's a cliche, but you need to build the shed for the cow, not the easiest place on the farm where the builder thinks it's easy and it's a more level site, and we can save on a bit of steel work because we can join onto the other shed. Let's think about the cows and get that space. That's the biggest one that I see regularly. Just adding on next to the shed, no space in between to maximise that natural ventilation.
Thank you so much. We do have a question, which is regarding cows' bunching behaviour. Are they bunching because of lighting or heat stress?
I'll go first and then you guys can add in, but they're bunching because of heat stress. However, when they're heat stressed, this is what I've seen from being on farm, when they're then heat stressed, the lighter areas of the building are what they're trying to avoid. So the bunching behaviour comes from a cow being stressed, being hot. However, the way the lighting in the shed can determine where those cows are bunching. So it's that instinct of, that lighter area, so that direct sunlight is hotter. Whereas when they're out grazing, it's the same natural behaviour. A dark area is the shaded area. So it's the bunching due to heat stress, but the lighting then can have a secondary effect on where they're bunching in the building.
I think we've also discussed it with yourselves at Galebreaker, but Marie, you might have a bit more on this, but the trouble you've got is learned behaviour from cows. So once they start to do it, even if you rectify the problem, they continue to do it. So it's a bit kind of getting in there first to try to stop that issue. So when they do start bunching, they kind of continue to do it, even when it cools off, so to speak.
Yeah, it's a tricky one. I haven't seen any research done, and it would be really interesting to try and delve into this, whether it's learnt or whether it's innate. Is it innate that you just go for the darker part, or there's probably a bit of both. Once they get into the darker part, it gets cooler, so that it's reinforced. But it'd be super interesting to look at it, actually.
Yeah, it'd be good to have some research come out on it. This is literally just from what I've been seeing on farms over the last 3 to 4 years. But it's definitely an area which could do with some research.
Do cows struggle more because our cows haven't acclimatised?
Yeah, that's a very good question. I think probably they do struggle more. I mean, there's been work in pigs that shows comparing pigs in Spain with pigs in Britain, and they do adapt. So if you're a Spanish pig, you're adapted to a higher THI than you are in the UK. So I suspect that 28, 29 degrees is going to affect a cow in the UK more than it would do in Spain, just because they're not used to it and they've adapted somehow. So yeah, I think that is an issue. Yeah.
Well, if there are no more questions for now, I think we will end that here. If you do have any questions, we do have the emails at the bottom, so feel free to drop our presenters an email. Thank you very much for listening, and I hope you have a lovely day.
Thank
you, everyone. Thanks.
Thanks, everyone. Thanks for listening.